In this video, I will show how to import a 3D structure, in this case a RF connector, from a step file in EMPro, save it in an ADS open access library, assemble it in PathWave ADS with any PCB and run a 3D EM simulation in RFPro. I started already EMPro and will import the cut file of the RF connector. First I go to File, Import, Cut Files. So we support many different formats, but here I have only a step file available. I choose the step file and open it. I would recommend to use healing, and if there is a material available in this structure, it will also automatically assign materials. Then I click OK. Then here we see then the structure. So unfortunately no material was available there, and therefore I need to assign the material manually. Therefore I go into the material and then select from default material library. So first I choose copper. Then I have also a Teflon included as an insulator. So this is this PTFE material, and I will also add later a solder. So here in the part list we have the assembly. So we have the insulator and the outer structure, the center pin, and here's some other body material. So we can also make another assembly here for some insulator, because this makes it easy to assign the material with with fewer mouse clicks. So I just choose here this copper and add it to here. So you see here now we have this material assigned to copper, and so we have also some insulator that I bring it here in. The next step is to add some solder at the center pin. So when I zoom in to this center pin, I notice that this is still a circle, and it's probably hard for the measure, and therefore we have a nice feature in EMPro. When I click on the complete assembly, make a right mouse click and choose Simplify and Heal, and click on Heal. And now when I go back to the structure, and now you see, now it is more or less a polygon, and this sensor simulation will later run much faster, and this is a big advantage. And also for me it is easier to draw. So now I will draw a structure for the solder. Therefore I choose here Extrude. So I need to change also the plane in which I want to draw. For example, here we are in the YZ plane, and I go here to Preset, click on YZ, and now I also choose an origin. This makes it also easier for drawing the structure. And now I go to the Edit Cross Section. I choose a rectangle, and it snaps now very nicely to this first point. And now I can just draw here this rectangle like this. And now I go to Extrude. And okay, so the length is okay, but you could just use here this arrow to move it around, or type here a number. So then I click OK. Then I have here now a solder defined. So I can have here another assembly. When I make here a solder, and later when we have all solders, we drag and drop just the material data down. So this is my solder material. We could also write here solder at the center pin. To make sure the ground of the connector with the PCB is properly connected, I will also add here on these faces some solder. Therefore, I go to create geometry, choose sheet body from faces. Then I click on the body, I click then on the first face, and then Control and left mouse button to the second face, and then type here a name, solder 1 for example, and click OK. So now I need to thicken these two sheets to have the same level or thickness as we have here in the center pin, to have a good connection to the PCB. Actually, this is the Z coordinate. So I only have to look to the Z coordinate. Then I click here to the measure, and now we see here the lower end is 0 and the upper end is 0.48106. So therefore, I just go here, make a right mouse click, make a modify, and then thicken sheet. And I put here 0.48106 millimeter. And then I click on done. Then I have both sheets thicken. So I also bring here the solder into the solder assembly. So the next step is the this interface. So this is the same procedure. Then I go to create geometry and then sheet body from faces. Then I click on this structure and then I choose here this face and also this face. And then we type here solder 2 and click on OK. And now on this solder 2, I go to modify and click on thicken, but here I only take 200 microns. Actually, 100 microns should be also okay, but in this case, I take 200 microns. Then I bring it down to the solder assembly, and now I just choose the material, the typical solder, and now I have also the solder defined. So next step is to define ports, because it is much easier to connect this connector later in the ADS layout and also define the ports in RFPro. So here on the end of the connector, I define a waveguide port. Then I make here a right mouse click on circuit components, ports, new waveguide port. Click on this little arrow and then on the face of the inner connector. Next step, I go to boundary extension. So I know the boundary extension. So I put here on each field 2.4 millimeter, which gives me the best boundary condition. And then go to properties, assign a 50 ohm voltage source. And now I also need an impedance line. So here in the center, I just put here the first point and the second point. Let me take here. Make sure that you are inside this bounding area. Otherwise, you get a yellow warning. So apply or done. Then this port is done. And here on this side, I will connect to the PCB. It is make it easier than when I have a port, so snapping. This is the reason why I put a port, because this port is not actually needed. Then I make here a right mouse click, go to new component. I don't need to define a new definition because we have already a definition, and then click on this little arrow and then go to the center, because then here you are really on the center. Then the next step, you click here and choose, for example, let me take this one, any port. If you want to have the same X coordinate, you can also change here the X coordinate that you have a nice port. So to make it complete, so you assign here also 50 ohm and then go to done or apply, and now our connector is finished. So in the next step, I will save this connector in open access library. So EMPro have two different kind of databases. So I click here on Save As. So you see here we have EMPro Open Access project, or you can just use a legacy. But in this case, we want to use this connector as a 3D component in ADS. And therefore, I save it as an open access. So if you see here this little symbol, this library symbol, then you have already a library. But when you don't have one, you need to click here on the symbols, then you can generate a new library, put a name there, and inside this library, you put then your connector. I have already an RF connector library, so I just put here my connectors there. Then I save it. I take here the name, for example, FCon6. And now I'm done. So now I have a 3D component which I can use in ADS. Here in my workspace, I have two different PCBs with a 75 ohm coplanar line. In the cell board_top, I will connect the connector to the top metal, which is the PC2 layer. In the cell board_button, the connector will be connected to the PC1 layer. On the right side is the ADS layout window with the 75 ohm coplanar structure. On the left side is the substrate definition. So here I have three lines. The center line is the signal line, which is assigned with the net name SIG, and the layer is PC1. So here we see in the substrate definition, the structure is at the button. If I want to place this structure to the top, so I can also change this here when I just change the layer. Okay, here I have the ground nets, left and right. And when you place pins here, and you have already assigned the net name, so the net name is assigned automatically to the pins. The dimensions of the substrate I assigned to the DIL layer. In the substrate, however, you have to define the FR core 4 as a bounding error layer, so that you have the exact size of the PCB in the 3D simulation. It is indicated in the substrate if you have defined the bounding error layer like you see here. In the ADS main window, we have three different views. So we have the file view. Here in the file view, you can navigate through the complete database to open another workspace and so on. And in the folder view, here you see all cells which are writable, which are in the workspace. And when you map any library, then you will see also all the cells. You can also manage the cells when you just create here different folder and move these cells into the folder that you have a better structure. In many cases, it is better to use a library view because with the library view, you see exactly which cells are in which library. So you can also explore here the library. So this is a workspace library. And actually, this is an ADS technology. You can also explore the technology when you go to right mouse click, technology and technology setup. And here you see which layers are mapped to this library and which units are used. Don't mix any units or change the units when you have already generated a new library. Better generate a new library with new units and resolution. You can also show other technology tabs like the layers, the purposes, and so on. In EMPro, we have saved the connector to an open access library. Now I will show how to include this library to this workspace. To include the EMPro library, you have to go to the File, Manage Libraries, and then Add Library. And now we can navigate through the database and use here this connector library. A good idea is always to make names of your libraries that it indicates that it is a library underscore lib or so, and also indicate that it is an EMPro library. So now this library is added. We close this dialog window, and now you see here I have all my connectors included. The next step, what I want to show is don't change here the technology. When you make a right mouse click and go to technology, technology setup, and it seems that is an incorrect library, but this is a 3D library. Just let it how it is, how EMPro generates this library. Don't change it anything. And don't add an ADS layout cell view to such a 3D EMPro library. When you add an ADS layout cell view to this library, ADS will try to change the technology file because here we don't have any layer, units or resolution defined. When this happened, your 3D component wouldn't work anymore. Please keep this library as a 3D EMPro library and create ADS layout cell views in an ADS library. In a 3D component library, you can also have different units and so on. For example, one cell has mils, the other cell has millimeter. Everything is covered inside the cell. But in an ADS library, you have for all cells the same units, the same precision, same layer, and so on. In the next step, I will place the 3D connector on my PCB. Here I have the connector RF library. Then you can open it, and I just use here the layout view and drag and drop it down to the layout window. Here you get the dialog window. Here you have to select the layer on which you want to connect the connector. So when I want to connect it as a button, then I choose here the PC1 layer because the PC1 layer is at the button. When I want to use it connect it on the top, then I have to use the PC2 layer and so on. But here I choose the PC1, and here you see also some other parameters. So you can also see if you want to rotate your component around the x-axis, y-axis, and so on. And this is also very important, the Z parameter, because the Z parameter, when you remember when I created the solder at the center pin, I showed a coordinate, the set coordinate. It was 0.48, but here I need to put minus 0.48 millimeter. Then I click OK, and then I connect this connector like this one. So my layout setup is finished. Now I can start RFPro. So RFPro now generate a complete 3D structure for simulation. So we see here we can also switch to the dielectric to solid, that we see the complete picture of the substrate. So see good connection here at the solder and so on. And now we go through the EM setup and run the simulation. Here in the left upper area, we have the design tree. So we have here two nets. We have a ground net and a signal net. When you click on it, then it's also selected. You can also hide the different visibilities like the conductors and also the dielectrics. And you only see here the shape what you have selected. And for example, you can also select here the component. But I switch it back to solid. And here in substrate, there are also some other features that you can also visualize the different layers. If you, when you make a right mouse click, set visible or invisible when you explore a multi-layer stack up. This is very nice in this way. But for the analysis, because we make here a complete analysis. So we have here in the analysis two types of analysis, a full extraction or a net extraction. But in this case, we make a full extraction, and therefore I make a new one, for example, it's a full extraction. So I just use the pins. So I have already in the layout defined a pin. So this is my plus pin, a signal pin, and this is a minus pin. If you don't have a pin on the layout view, you can also generate virtual pins. So I just drag and drop this pin down to the ports, and now we have a plus minus pin. But the third one port did not go with this down, so you can also have a ground signal ground pin or port. And on the other side, we need also a port, and therefore you can go, it's very easy, you go just to the component, and so you see here, you have, here's a plus pin. You just drag and drop it down to the ports, and now we have also a plus minus pin here. So you can also now configure the ports, because here we don't have a standard port. This is a 75 ohm port. And therefore we use here also 75 ohm port. You have also the possibilities that you use a waveguide port or use automatic and so on. Here we do the same with input pin at the board. Then we have here a 75 ohm port and use a transmission line or waveguide port. The next step is to define the simulator. In options, you can choose a frequency plan, either adaptive, logarithmic, linear, or single. Here I choose from 0 to 2 gigahertz. And you can also store the fields. And here in the simulator, I choose here the FEM simulator because I have a 3D structure there, and therefore I need to use the FEM simulator. When I click here on this little button, then we for this simulation we need to use generation 2. Generation 1 will not work with 3D components. Here mesh domain optimization is off because I also want to look to the near field, and I use here conductor edge mesh. That's all. So all other can be automatic, and then I click OK and done. And now I double click here on run to start the simulation. The simulation took a bit more than 2.5 minutes on my laptop. So the next step is now we want to look to the S parameter. And therefore, I go into the results folder and double click on S parameters. And I can just visualize S21 or S11 and so on. You can also change here the reference impedance. When you click here in this field, and just change the impedance when you want to have. You can also change here to different values, set parameters, resistance, inductance, because inductance you sometimes want also to see. So now I want to also look to the near field. We double click on the near field because it was also calculated. Now I choose here a frequency. Let's take 666 megahertz and click on cover. And we have two. So this is a cover of the 3D component and the cover from the PCB. Then you can also choose here the E field or take the surface currents. Here you can also change the automatic range, so the properties, let's take here 1 ampere per meter. Now you can go to the sequence and run through this, so through the phase from 0 to 360 degrees. I also want to provide more information about the orientation, how the connector can be placed. First, we need to figure out how to connect the connector to the board. On the left lower area, you see the orientation of the coordinate system. The Z arrow points to the upper area. When I don't rotate the structure, the connector will be mounted to the bottom of the PCB. When I want connect to the top of the PCB on layer PC2, then I need to rotate the structure. Here we have two options. I can control the orientation in ADS in the 3D component with parameters. Therefore, I need to change to the layer PC2 and the custom component rotate X parameter to 180 degree and click apply. And we also need to put here 0.48 millimeter instead of minus. But it is also possible to rotate the complete structure, that you just place it with the default parameters. In this case, we see also that the connector is mounted correctly. In case if you want to use this connector many times and connect it to any PCB, then I would recommend to move the z-axis of the complete structure. Therefore, I put all structure in one assembly. So I have here a top hierarchy, so one assembly, and all are inside, so the metal, the outer, the insulator, and the solder. And now I just make here a right mouse click, click on modify, specify orientation, and now I just put here the number 48106. Click on done, and now when we measure it here, so we have here exactly 0. That's all. And now when I import this or place a component on the ADS layout window, I don't need to change the set parameter because I just define the layer on which layers this connector will be placed. Okay, that's all for today. Thanks for watching.